Hey guys, welcome back. In this video, we're going to provide two levers for the designer to pull: reaction control system thrust and main thrust. And by the end of it, we will have a different feeling game because we can rotate faster. And right here in the inspector, even when we're playing, we're going to be able to tweak these values and see what feels best. So I'll see you in there. I don't know about you, but I am loving how this project is coming along. Now, the biggest thing that is griping me about it at the moment is that my ship does not rotate fast enough. And also, I think I might want a little bit different thrust. And just playing around with the mass of the ship is now no longer enough. This mass is ridiculous anyway. It's notionally kilograms, so my ship is 10 grams. It doesn't kind of matter, but it does matter that I can't rotate. So I'm going to show you a completely different way of doing things. So inside our rocket script, what we want to do when we thrust, we want to be able to choose a value with which we thrust, both for thrusting upwards and also for our rotation. Okay, because at the moment we're using what we call unit vectors, or vectors of length 1. This vector 3.up and vector 3.forward have a total length in 3D space of 1 unit. Like, one way of visualizing that would be these arrows on the screen now have a length of 1 unit. Okay, so we need to make these things bigger. So let's just talk a little bit about multiplying vectors. If you multiply a vector by a float, then you end up with a new vector. That new vector is parallel to the original vector, and it's along the same line as the original vector, but it's a different length. And it works for rotation and translation. So let's take a look. For example, vector 3.up has a length of 1, and it just turns out that we've tweaked our mass and that our rotation happened to be such that it's kind of acceptable, having a vector length 1 for the thrust and a vector length 1 for the rotation, but we want more. And to get more, we multiply that vector 3.up by 2, for example, just gets twice as long. So the way that I'm going to do that is I'm going to make myself a floating point to multiply by, and I'm going to call it rotation speed, for example. And then what that's going to be is it's going to be something that should be frame rate independent. Remember, we saw time.delta time before. And then times some value. I'll do the times in front. So I'm going to call this RCS thrust times time.delta time. So RCS thrust becomes a parameter that I can use, and now I can multiply all of this by rotation speed. So look, I need to slow down and go through this with you again. But first, let's make a variable for RCS thrust. I'll just make it up here just for a moment. Var, or float, RCS thrust equals, I don't know, 10F for float. When you initialize a floating point value, you need to put an F after the number so that it turns this thing into a float. If you just say 10, you may get an error that says, I'm not sure what this number is. Or it may treat it as a double by default, but you're better off just, and the double is a longer floating point number, you're just better off saying F, and that will get you out of trouble in a lot of cases, all right? So if you mean to put a float in there, put F. So if we have RCS thrust is 10, then we get a rotation speed that's based on the thrust, which is a lever that we're going to be able to pull, and eventually we'll be able to pull that in the inspector, and you multiply it by the frame time, then you get a rotation speed. So if it's a longer frame time, then you need to rotate further. Now, rotation speed is probably a bad name, so let's immediately rename it. Rotation this frame is clearer. So the moment you spot a clearer name, go for that. Then we're just going to scale up this forward vector into the screen. Remember, rotations are weird. The vector goes into the screen, but you rotate clockwise or anti-clockwise, depending on whether you're left or right-handed. In this case, we are a left-handed coordinate system, so a vector 3.forward into the screen. You put your thumb into the screen, your fingers coil around anti-clockwise, and this is where you get your A key doing anti-clockwise rotation. But if you make that what we call torque vector longer, a vector that is about twisting, then by multiplying it, then it goes faster. All right, so that would allow us to rotate left at a different speed. Now, we don't know if this speed is appropriate. Let's try it. It's only left that's going to be affected. So right goes like that. Left is too slow. So it looks like we need an RCS thrust of more like 100 to be reasonable. And let's try. We should now be able to rotate left faster than right based on what I've just done. Ah, that's better. So right's very slow and left is faster. Awesome. So, I keep going to the repo. So what I'm going to do is exactly the same treatment now for the other part of the if statement here. Oops, here we go. grab that, pop it in there, and now notice that this code is duplicate. Oh, by the way, we need to do the multiplication. Sorry, there you go. So the only difference between these two clauses is this minus sign. So because of that, we can take this calculation about the rotation this frame, and instead of repeating ourselves, remember, don't repeat yourself, you could put it just above here. So you're just moving it out of the if statement, and now it is available to the entire method or function because it's at this level of indentation. It's available to the entire function. Okay, so we're nearly there. We now have a variable that we can change the thrust on, and if we come in here and play the game, we can turn right and left, and we're nearly there, but we have a challenge. I would like to be able to change this value on the rocket shipped script here. You see how all these other components have these things you can adjust, numbers you can adjust. That's what I call an inspector lever. It's something that, as in a lever you can pull. It's something we want the designer to be able to tweak. In general, when you think about your relationship between you and the designer, or you with your designer hat on, you should literally not be going into Visual Studio at all when you have your designer hat on. You want to be making the best of what you've got. And Rick will be mirroring that by generally not coming into Visual Studio at all. And that keeps us honest to giving the designer the levers that they need to pull. Or when it's you on your own, you want to be saying, no, I'm not coding right now. I'm focusing on making the game more fun. So to make it available in the inspector, what we need to do is firstly make it a member variable. So our thrust now can come, let's just space it out like this. Our thrust variable can come to the top of the code like so, somewhere like that. Now, it is not yet available in the inspector, just like these things aren't available in the inspector. And there are two ways of making it available in the inspector, and I want to talk you through them. So there's SerializeField, which we can put in front of it, and that would allow you to change it in the inspector, but it would not allow you to change this thrust from other scripts when we write other scripts, which is a good thing, by the way, because we want this script to be self-contained. The other option is that you make it public. It has a side effect of allowing you to change it in the inspector, but the real purpose of public in C# is to make that value changeable from other scripts, which is a bad thing. Because we don't, if we have some bugs or concerns about what's going on with our rocket thrust, we want to restrict the number of places it could have possibly changed. Okay? And in the inspector is the only place it can change if we use SerializeField like this. So that's what we are going to get in the habit of using. Now, this value you put in is a default value. What it means is the first time that you create a script, you add a component rather, with the rocket component to a game object, it's going to start with the value 100. So if I take a new game object, an empty game object like this, and I add a rocket component, then that RCS thrust default value is 100. RCS stands for Reaction Control System, as I said before. So we've got a lever in the inspector now. Let's try it. So you play the game, same as before. If you change this at runtime, you're just experimenting. So if I changed it to 1,000, whoa, madness, okay? And note when I stop playing, it goes back to 100, which lets me safely explore values inside play mode without affecting the values when you get out of play mode. So I reckon it needs to be more like 250. It's now bold because it's different to what? Because it's different to the prefab, right? If I click apply, it's going to set 250 back to the prefab, which means that the first place it looks is here for 100 when it first adds the component. Once you've added the component, the next place that it gets it from is the prefab, here 250, it's set on the prefab, and then that can be overridden again in the case of the actual instance of the rocket ship right here. If you change the value here, it's now different. So we've now got 300 here. Bit confusing, maybe, but not too bad. The value in code tells the component what value to take when you first add the component. The value on the prefab tells the prefab what value to take when you first drag that prefab into the world. So let's make a new rocket ship prefab here. Okay, that's the prefab value, and then the value on the actual instance of the rocket may be different to that, may not. So I'm going to go with 300 and see how that looks. Okay, it's good, but it's only fast one way. It's only fast to the left at the moment, so let's go and look and see why. RCS thrust, let's follow it through. That's because I have inadvertently not multiplied by rotation this frame in there. Okay, so here's the final code in here. You just calculate a rotation this frame, multiply up your rotate vectors by it, and off you go, and you've exposed it in the inspector. Now, I have got a challenge for you, which is to do the same thing for main thrust. Make a main thrust variable, serialize it, and it should be adjustable in the inspector. The ship's rigid body component should be reset, so I want the mass of the ship's rigid body to go back to 1, and then the ship should handle similarly to before. So I want you to find a main thrust value that works. And enjoy fooling around with your ship. So have a go. See if you can do the same sort of treatment with main thrust. It's simpler than what we just did. All right, so briefly, this is it. I'm going to copy what we had, and I'm just going to paste it in. I'm going to change this to main thrust. Leave it as 100 as an initial guess as to a sensible default. The values you choose here should just be sensible defaults. Beyond that, the designer can set these in the prefab and in the instances in the game world. Then what we want, if we have a main thrust here, is we just want to multiply when we thrust vector3.up times main thrust. Should be as simple as that. Back into the game world, I'm going to reset, as I said, the rocket ship's component altogether so that the mass of the rocket ship becomes 1. Note that'll change my drag. So if you lost your drag value, then there's a couple of options you have. You can go look at the prefab, that'll still have the 0.2. Well, that's the easiest way. So I'm going to put the 0.2 back. The main thing is that I got the mass to 1 to prove that I now have a different set of levers. Let's see. Oh, that's too much thrust, right? It's the rotation is probably good. Let's just check the rotation. Yeah, the rotation is nice and snappy, but the thrust is too much. So you come in here and we reduce the main thrust down to, say, 50. And the RCS, actually, it's rotating a bit fast. 250 for the RCS, the reaction control thrusters, 50 for the main thrust. That's good. I like that. And because I like that, I'm going to apply it back to the prefab, and that's good. You see how you've got lots of different opportunities to play at playtime or on the instance in the hierarchy or on the prefab, and it's all good. So that's it. Congratulations, you know how to use SerializeField. You can now create levers for your designer or the designer part of yourself to pull, and we're in good shape.